The metric system has a huge advantage over the US system in that it makes for different sizes of units, different magnitudes of units, and conversion of units so much easier. Okay? In the US system, you have to keep track of all these different conversion factors to move from one unit to another. So say I'm measuring my own weight. If I am measuring in ounces, I have to know that 16 ounces is 1 pound if I want to go back and forth between those, okay? And so if I only have something that can measure in ounces, I'm gonna have to convert to pounds using some math, okay? Because ounces is too small of a unit. In the metric system, changing a unit doesn't actually change the base of the unit. All we have to do is tag a little prefix on the front of it to tell us how big or small that version of the unit is. So take the meter, for example. The meter is our metric base unit for length or for distance, okay? So 1 meter is one basic way we can measure length, and you can have multiple meters in a measurement or part of a meter. But if a meter is too long, just way too long for whatever I'm measuring, I can use a smaller version of the meter, like a decimeter. A decimeter is just a fraction of a meter. It's one little small piece of it, okay? There are 10 decimeters in 1 meter, okay? And if that's still too big, I could go even one version smaller and go to the centimeter. There are 10 centimeters in 1 decimeter, or 100 centimeters in 1 full meter. So on our meter stick, this goes out to 100 centimeters, okay? And this meter stick down here goes to 10 decimeters. All right. Now, if centimeters is still too big for whatever I'm measuring, we can use millimeters. Okay. There are 10 millimeters in 1 centimeter. So on your meter stick, if you count the little tiny, tiny dashes in between each centimeter, like in between 10 and 11, there's 10 millimeters there. Okay. All those little decimals, basically, from 10 to 11, 10.1, 10.2, 10.3, all those little 0.1s and 0.2s and 0.3s are actually millimeters. Okay, so there are 10 millimeters in a centimeter, or there's 100 millimeters in a decimeter, or there's 1,000 millimeters in 1 meter. Okay, now a millimeter is so small, I couldn't even draw 1,000 of these. I had to kind of cheat and just make them as tiny as I could. The marker tip is too thick to draw that many millimeters, so I got about 400 in there. So don't actually try and go and count them, because there's not actually 1,000. Okay? Now, in all these cases, I'm still using meters to measure length. Okay? But I'm using different versions that mean different sizes of that unit. Okay? I can also go bigger. So instead of using a meter, if I'm measuring a length that is longer than that, I can do something like a decameter. A decameter is the size of 10 meters. Okay? I could do a hectometer, which is 100 meters, or 10 decameters. Okay? And you could even do a kilometer, or a kilometer is how we usually say it in the US, okay? Which would be 1,000 meters, or 100 decameters, or 10 hectometers, okay? Now, the nice thing about this is we don't have to keep track of all these tens, hundreds, and thousands and all the little factoids that I'm saying, because all of these differ by a factor of 10. What else differs by a factor of 10? Well, that's your decimal place. When you move a decimal place around, you're just changing by a factor of 10, either multiplying by 10 to make something, the number bigger, or dividing by 10 to make the number smaller, okay? I guess from this angle, yeah, okay, I'm doing all right. Let's check my lefts and rights here. Okay, so we can change the prefix of a metric unit, okay, and therefore the size of the unit, just by moving the decimal place around. No math required. We don't have to do any punching into the calculator. We just move the decimal place, okay? Now we have a handy chart that we can use to just kind of figure out which way the decimal point goes and how many spots it goes. And each one of these is different by a factor of 10, aka 1 decimal place. So as long as you keep track of that and just move on the chart the same way you move your decimal place, converting metric prefixes is actually really easy. So we can go between big meters, small meters, something in between, any version of the meter that we want. Okay? The other great thing about this is you can do this with other stuff besides the meter. For instance, this is 1 gram. Like, you might not even be able to see it. I don't even know if the camera is going to be able to focus on it. But let me see if I can get it close enough, and hopefully the camera will be able to pick up on it and see it there. So that's 1 gram. That is very small, okay? Most of the stuff that we measure in the lab is gonna be bigger than a gram, okay? So if you wanted to measure a whole lot of grams, like say something like me that has a lot more mass than this little tiny guy here, you might use a version of the gram that's larger, like a kilogram, okay, or a kilogram, all right? A kilogram is like this. So it might be easier to count my mass in kilograms rather than counting it in little tiny baby grams, all right? My mass at the moment of recording this video comes out to be around 70 kilograms, okay? So you can change the meaning of how big or small that unit is just by changing the prefix, which comes on the front of the unit, okay? And it can either be the full name, like kilo, or it can just be one letter to represent it, like this K in kg represents kilo, like kilogram or kilogram, okay? Same thing goes for liters. It goes for seconds. So we were measuring in this lab in milliliters instead of full-on liters, okay? A full liter would be something like this, okay? This is an 1,000 milliliter beaker, so it holds 1 full liter. Put that over there. If you've ever ran a race and you're timing yourself, you might measure your time down to the millisecond, okay? So that's just a smaller version of the second, okay? It's a fraction of a second. It's 1,000th of the second, okay? But it's just a way to measure smaller bits of time, okay? Now in general, as you make your unit smaller, like going to centimeters or millimeters, your number gets bigger. So it helps us to measure smaller things. So instead of having to say, oh, I've got 0.001 meters, I can say, oh, I have 1 millimeter or whatever. Same goes for any other base unit. Okay, so we can do this for grams, we can do it for liters, we can do it for meters, we can do it for seconds, and we can even do it for joules if we're measuring energy. You can have kilojoules and millijoules of energy, and whatever other prefix you want to tag onto it to make the unit fit what you're measuring. Okay? And this can help us make our data look a little bit nicer and a little bit easier to digest and visualize if our measurement tool only gives us a couple options. Like our mass balances only give us our units in grams. So if we need to change the unit to make it a little bit fit better, we can do that pretty easily just by moving the decimal place. Okay, let's look at some examples of how we can change the size of a unit just by moving around its decimal place. Okay, so in this first example, let's see, I have a mass of 70,250 grams. And that sounds like a terribly huge number. It makes me feel bad about myself. So to make me feel a little bit better, we're going to convert the number into kilograms. Then that's going to make this number smaller because the unit will be bigger. Now it'll mean the same amount of mass. It's not like I'm going to be made of less stuff. So really it shouldn't change how I feel about it, but it's going to look a little bit nicer because the number is going to be more compact. Okay, the unit that we're talking about is a larger amount of mass, and so we need less of those units to make the same amount of mass. Okay, so to do this conversion, we're going from grams to kilograms. Okay, now grams is what we call a base unit. It has no prefix on it, so we're going to be starting here. Okay, now other base units include meters and liters and seconds, joules, and liters. I might have already said liters. Meters, liters, seconds, joules, grams. Okay, I might have said one twice. Anyway, but all of those are base units, no prefix. Okay, now if I want to change the size of that unit, all I have to do is see how I move on this chart and then make my decimal point do the same thing. So if I go 1, 2, 3 spots to the left to change this from regular old grams to kilograms, my decimal point is going to do the same thing. It's going to go 1, 2, 3 spots to the left. So past this 0, past this 5, past this 2 to land where the comma is. So this 70,250.0 grams is the same as saying 70.250 kilograms. Okay, now after the decimal place, any extra zeros that just kind of tail on the end don't really change the number. So if you wanted, you could write it like this, or you could write it like this, and it would be the same answer. The extra zeros at the very end don't change anything. Okay, so either way you want to write it, if you want to keep the zeros or not, is fine. Okay, but 70.25 kilograms is the same amount of mass as 70,250 grams. It's just a matter of how it looks and what size of the unit that we're using. So let's look at another example. Okay, so let's scroll down to this next page. Okay. So I've got this magnetic hourglass that I can turn over, but it doesn't actually take an hour for all the iron filings to drain down on the bottom and make a cool little pattern. Instead, it takes 3,015 centiseconds. Okay, so this is a version of seconds that's already got a prefix on it. We're going to change it back to regular seconds this time. So let's use a different color. Let's do blue. Okay, so in this case, I'm already starting with a prefix. I'm starting with centi, which is right here. Okay, I want to move to regular seconds, which is a base unit with no prefix, right here. So I'm going to have to go 2 spots on my chart to the left. So my decimal point is going to do the same thing. Now, I don't see a decimal point here on my number. So if it's missing, it's actually at the end. We're just not showing it. So I'm going to put my decimal point where it belongs, which is at the end of the number, if it's not being shown. And now I can move it 2 spots to the left. So let me see if I can zoom this in a little bit. That's a little better. Now I'm going to go 2 spots to the left. So I'm moving past the 5 and past the 1. So 3,015 centiseconds is the same as 30.15 regular seconds. Okay, which looks a little bit nicer. It's a little bit easier to understand. Okay, so again, we can easily convert from one unit to another and different sizes of different units in the metric system because we're just moving around the decimal point. We're just changing by factors of 10. Okay, let's look at another example. Okay, my front desk is about 3,648 millimeters long. That's a lot of millimeters. Okay, but that's a lot to imagine, having that many millimeters. So instead, we're going to convert that to meters. Okay, so millimeters might be too small of a unit for such a large length, so we're going to convert it. So let's do a different color. Let's do pink. All right. So I'm starting this time in millimeters. So I'm starting at the milli prefix here, and I'm going to meters, which again is a base unit. Okay, no prefix. So we're going to move 1, 2, 3 spots to the left, and our decimal point is going to do the same thing. So again, there is no decimal place here shown, but I know it's got to be at the end of the number if they're not showing it to me. So my decimal point's right there. Let's zoom this in a little bit. So my decimal point is going to move 1, 2, 3 spots to the left, which means it's going to be right where their comma is. So that's going to be 3.648 regular meters. And that's my answer. Okay, not too bad. Okay, next one. My water bottle can hold up to 0.12 decaliters. Okay, deca and deci are really easy to get confused, so make sure you're careful about those. Deca is DA, deci is just a D. Okay, so if I were talking about deciliters, that would be just DL. Okay, but decaliters is DAL. Okay, those are 2 different prefixes that look very much the same, and so they can be easily confused. Okay, so I'm going from 0.12 decaliters, DAL, and changing it to milliliters. Okay, I don't always have to stop or end, or start or end at a base unit. I can go from one prefix to another. So in this case, let's use green. I'm going to go from deca, DA, right here, over to milli, all the way over at the end, right here. So I'm going to be going 1, 2, 3, 4 spots to the right. And this does count as a spot to cross over, okay? Because the base unit is still a unit. It still has, a size. So we're going 1, 2, 3, 4 spots to the right. So on my number here, I'm going to go past the 1, past the 2, and then there's nothing else to go past. So what we do is we go past some invisible zeros, okay? You could have as many zeros on the end of this as you want. You could say this is 0.1200000000000. It's never going to change the value of the number. So I can just keep moving past numbers until I get the decimal place where I need it to be. So I'm going 4 spots to the right, past the 1, past the 2, past a 0, past a 0. So my answer is going to look something like this. 0. Oh, wait. Oops. Sorry. Let me back that up. It's going the wrong way. It's going to be all the way down here at the end. So I'm going to fill in zeros here and here. So it's going to be 1, 2, 0, 0. And then my decimal point, milliliters. Okay, so 1,200 milliliters is my answer. Okay, so if you're moving past blank spots, just fill in zeros there. All right, last one. So I've got my bouncy ball. I'm going to hold out at arm's length, ready to drop. It has 0.0005292 kilojoules of potential energy, just waiting to convert into kinetic energy and some thermal energy. Okay, so we want to convert kilojoules into decijoules. So we're going from a prefix to a prefix again. So let's see what we have to do to get from there to there. So kilojoules, this K here, kilojoules. The prefix is kilo, K, right here. Okay, and I'm changing to deci, which is just the D on its own. So I'm moving 1, 2, 3, 4 spots to the right. Okay, so this isn't the only time I've moved 4 spots to the right. Okay, but I'm doing it from a different unit to a different unit. Okay, it doesn't really matter where you start and stop. What matters is how many spots you go and in what direction. Okay, so as long as you know where you start and where you stop, you can figure out any of these conversions. So I'm moving my decimal 4 spots to the right. My decimal is right here. So I'm going to go and past this 0, past the 0, past the 0, past this 5, and ending right there. Okay, so this is going to be 5.292. And now my unit is DJ for decijoules. Okay, now all these zeros in front won't really make much sense if I leave them there. You know, when you say 5, you don't say 0.5, and you certainly don't say 0.005 either. You just say 5. So kind of like zeros trailing at the end, zeros at the front don't really affect your value, and so we don't really need them. So I'm going to get rid of them. So my answer is going to be 5.292 decijoules. And that's it. So again, as long as you know where to start and where to stop with your prefixes, okay, your decimal point moves the same number of spots in the same number of same direction as what's on this chart. Okay, if you can keep track of that, then hopefully metric conversions will be pretty easy.